In this video, we pop the hood to understand exactly how heart rate correlates with your body's three biological engines. Your heart rate monitor is essentially a tachometer for your metabolic engines, the phosphagen, glycolytic, and oxidative systems. While we often speak about zones, biologically, these systems don't operate like light switches. They work like dimmer switches, blending together based on demand. At any given heart rate, one system is dominant, dictating whether you are burning limited glycogen stores or nearly infinite fat reserves. Understanding this blend is what separates random jogging from physiological training. Let's start with the oxidative system, which dominates your zone 1 and 2 efforts. Here, your mitochondria act as power plants, utilizing oxygen to convert fatty acids into ADP, a process that is highly efficient but slow to ramp up. This is why Zone 2 is often labeled the fat-burning zone. Though that's a slight oversimplification. You aren't just burning fat, you are training your body to prioritize fat as fuel at higher intensities. This mitochondrial density is the foundation of endurance performance. As your heart rate rises, you hit the crossover point, a concept popularized by exercise physiologists Brooks and Mercier. This is the physiological tipping point where the demand for energy outpaces the slow oxidative process, forcing the body to switch from primarily burning fat to burning carbohydrates. This shift isn't instantaneous, but tracking your heart rate drift allows us to estimate where this metabolic inflection point occurs. If you constantly train above this point, you erode your metabolic efficiency. Entering Zone 3 and 4, the glycolytic system takes the lead, breaking down glucose rapidly without requiring as much immediate oxygen. This production generates lactate, which, contrary to old myths, isn't a waste product but a potent fuel source that needs to be shuttled back into the mitochondria. Your rising heart rate here reflects the body's desperate attempt to clear conflicting metabolic byproducts and maintain blood pH balance. This is the burn you feel. It's chemistry, not just effort. Finally, we have the phosphagen system, used for explosive sprints, which bypasses heart rate monitoring entirely. Because heart rate is a lagging indicator, taking 30 to 60 seconds to catch up to demand, it provides zero useful data for 10-second bursts. When tapping into this immediate ADP pool, you are flying blind regarding metrics, relying purely on neural drive and mechanics. This is why we don't use HR zones for neuromuscular sprint work. The ultimate goal of heart rate training isn't just to stay in a zone, but to achieve metabolic flexibility. This means training your body to sustain higher speeds while remaining in an oxidative, fat-burning state for longer. By respecting these biological boundaries now, we push the crossover point to the right, allowing you to run faster at the same heart rate over time. In our next episodes, we will look at how to test these thresholds yourself. Thanks for watching, and join us next time as we debunk the myths of max heart rate formulas.